Okay guys, so we're going to do an example in which we are trying to find the coefficient of kinetic friction. So we have a 1 kilogram block sliding on a rough horizontal surface, and 4 Newton force is applied so that the block accelerates at 1.2 meters per second squared. We want to find u sub k. So the first thing we do is draw our situation. So we have a 1 kilogram block resting on a rough horizontal surface. We don't know the coefficient of kinetic friction, but we're going to find it, so we're going to leave that as a variable. On our object, we have the force of gravity pulling it down, normal force perpendicular to the surface, applied force in the direction of the acceleration, and the force of friction opposing that acceleration. So the first thing you want to do is draw a free body diagram. So go ahead, pause the video right now, do that yourself, check it with mine. Seriously, pause the video, draw your own free body diagram, and then check it with mine. Okay, so the free body diagram for our block should look something like this here. Now you're going to take those forces and you're going to break them into x and y components using that force diagram. So our normal force is positive in the y and 0 in the x. Our applied force, we know it's in the x, it's to the right, so it's positive. We're given that it's 4 newtons. Force of friction, not sure what it is, but we know that it's acting to the left, so it's going to be negative force of friction in the x direction. In the y, we have the force of gravity acting down. Right now what I'm going to do is substitute in mg for the force of gravity on my force chart. We should be used to doing this by now. We know that the force of gravity is a mass times the gravity. Again, negative because down. So our object is moving, right? It's moving in the direction of our applied force, so it's moving to the right. So we are going to have an acceleration to the right, no acceleration up or down. So sum of forces in the y are going to be equal to 0. Sum of forces in the x are going to be equal to ma. So let's take our forces, sum them, according to x and y. Okay, so let's start with the y. Sum of forces of the y are equal to 0. So we're going to have F sub n minus mg equal to 0. Move that mg over to the other side to get F of n equals mg. Let's plug in what we know. So we know it's 1 kilogram times 9.8 meters per second squared. Our normal force is going to be 9.8 newtons. So we're going to use this later to help us look at our force of friction. So leave a box on the side. Let's move on to the sum of forces in the x. Again, we know we have an acceleration in the x, so it's going to be equal to ma. In the x, we're going to have negative force of friction plus 4 newtons, our applied force, equals our mass, 1 kilogram, times our acceleration. Our acceleration is going to be 1.2 meters per second squared. So over here, I'm just going to simplify to 1.2 kilogram meters per second squared. we know that a kilogram meter per second squared is equal to a Newton. So let's make it Newtons. We'll leave the left side of our equation exactly the same. Now we're going to subtract 4 over to the other side. We get negative force is equal to negative 2.8. Let me just double check that that's right. Yes. Negative force is equal to negative 2.8. Multiply both sides by negative 1 to get the force of friction, which we know is going to be equal to 2.8 newtons. Great. Well, for force of friction equal to 2.8 newtons, that's fine, but we're going to need to know mu for the next part of our example, part B. So what we're going to do, we know that the coefficient of kinetic friction times the normal force is equal to the force of friction, so we're going to plug in for that. So mu k times F of m is equal to 2.8 newtons. We know that F of m, we solve for it right over here, is 9.8 newtons. So our value for mu is going to be 2.8 divided by 9.8. We're going to get 0.285. So we're going to put 0.29 is our coefficient of kinetic friction. So now we're going to move on to part B. So I'm going to pause to erase the problem. I'll be back in 1 second. So what we're going to do is we're going to say that the applied force has been increased to 5 newtons for the same object. But now we want to find the new resulting acceleration based on that change in the applied force. So we still know that our mass is 1 kilogram. The mu sub k, which we just solved for, which is 0.29, still applies. We're on the same surface, right? Surface doesn't change. The coefficient of kinetic or static friction will not change. We just need to find our new value for A. So again, same free body diagram, F of A is going to have a different value. So redraw your force diagram, pause the video, redraw it, and then check yours with mine. Okay, so we have still force of gravity down, normal force up. To the right, we have applied force. To the left, we have the force of friction. From that last problem, part A, I took that the weight, or the force of gravity acting the object, is negative 9.8 newtons. And then that new applied force is going to be 5 newtons. We're going to do the same thing. We want to sum the forces in the y and in the x. Sum the forces in the y are equal to 0. So we're going to get our normal force minus 9.8 newtons is equal to 0. Our normal force is going to be equal to 9.8 newtons. Let's move to the x. The sum of the forces in the x is going to be equal to m times a. Why don't you try that out right now? Pause the video. You're going to get negative force of friction plus 5 newtons is equal to 1 kilogram times A. Plug in for the force of friction. We'll use mu k from that last part, 0.29, and then simplify, solve for A. Pause the video to do that. And check your value with mine. You're going to get 2.2 meters per second squared. You can now do